Solving equations containing irrational expressions. In other words, solving equations that have fractions in them. Now, first thing you want to do, that I don't have here, but I should have here, you want to factor anything that needs to be factored in the denominator first, no matter what. And then you find the LCD of all the terms in the equation, both sides of the equal sign, not just the left side or the right side, both sides. Then you multiply each term on both sides of the equal signs by the LCD. When you do that, you will see the denominator start to cancel out. And then you'll continue as you always would as far as solving. Sometimes you may get a quadratic equation that you have to solve by factoring, but that's okay. And then the last thing is, since we're going to have the variable in the denominator, we got to always check for division by 0. So let's just do a few of these and you'll pick up the process as we go. Hardest part, as always, is finding the LCD. First example, let's find the LCD of 3, 4, and 2. Here's what I recommend doing. I recommend writing multiples of the largest denominator, in this case 4. So you think 4, 3 won't go into 4, 8, 3 won't go into 8, 12. 3 will go into 12, 2 will go into 12, yeah, therefore the LCD is 12. So now what you want to do is start multiplying each of these by 12. So I'm going to write it down like this. You can use parentheses, which I highly recommend. It's okay if you don't. Now what I'm going to do, I'm going to write each of these 12s over a 1. And then we're going to simplify each product of fractions that we have. So you can multiply straight across and then reduce, or do what I do, and let's reduce first. 3 goes into 3 once, 3 goes into 12 4 times. When you multiply that out, you get x times 4, which is 4x over 1, which is 4x. No denominator besides a 1, and we don't care about 1s. That's what's going on. We're eliminating the denominators. So in that case, we know that 4 and the 2 are both going to 12 because that's what the LCD is. It's what all these would divide into, or cancel into. That's another way to think of it. So this 4 cancels into 12 3 times, and it leaves the plus 21 equals. The 2 cancels into the 12 6 times, and it leaves 6x. And now we have just a regular old linear equation that you better know how to solve. And so let's continue on. I want the x is on one side, constants on the other, so I'm going to take the 4x away. Always start, well in this case, take the 4x away. 6x minus 4x is 2x. I'm going to divide both sides by that 2. And we're going to get 21 halves. I know that's the answer because there's no way I'm going to get division by 0 because there's no x's in the denominator. And I'm done. That's the process. Here we go. I'm going to do a few more. Yep, you will start seeing variables in your denominator. So let's find the LCD. Start with the numbers. The smallest number that 3 and 6 both divide into evenly is the 6. What's the most number of x's that you have in either place, or in any fraction, or any denominator? Just a single x in either place. So I just need a single x. Now once we have the LCD, what we're going to do with it is multiply each of these terms by the 6x, which is the LCD. Let's take 5x times 6x plus 4 over 3x times 6x equals 1 over 6 times 6x. Now, I'm going to cancel. That's the reason why I have the LCD. That x cancels with that x, leaving 5 times 6, which is 30. These x's cancel, and 3 goes into 6 2 times, so I have 4 times 2, which is 8. These 6's cancels, and it leaves 1 times x, which is x. And then I take 30 plus 8, which is 38. And that's what x equals. If I substitute it back in, there's no way I'm going to get division by 0. So therefore, I'm done with this example. Let's go to another example. This may be a little bit more fun. I don't know. Let's start with the LCD. That's where it all begins. Now, anytime you only have one fraction, that means your LCD is always that single denominator. The reason being because that 2 is over 1, the x is over 1. 1 divides into anything, x divides into itself, so therefore the LCD is x. So I'm going to do the same process. I'm going to multiply the 2 times the x, and the 15 over x times the x, and the x times the x. Now, nothing to cancel here because it's all multiplication, and 2 times x is 2x. These x's cancel, and it leaves the 15, and this x times x is x squared. Now this one is slightly different because of that x squared term, but the process is still the same as far as dealing with the killing or eliminating the fractions. We no longer have any fractions. Since we have x squared, we need to get everything on the same side as the x squared, and the other side should be a 0. So the process is to subtract the 2x from both sides and the 15, which gives us 0 equals x squared minus 2x minus 15. The reason being, we need a factor of this x squared minus 2x minus 15. So we can set each of those factors equal to 0 and solve for x. Now when I factor, I don't see a common factor. I don't see 4 or more terms. I do see an x squared with no number in front besides the 1. So I'm going to do the full method backwards and do what times what is x squared? X and x. What times what is negative 15? It gives us the negative 2. I know I can't get from 1 to 15, but I can from 3 and 5 if I make the 3 a positive and the 5 a negative. So that's how it factors. And then, since it's in factored form equal to 0, I'm going to use the 0 factor property, or whatever the book calls it, and set each factor equal to 0. Now I'm going to solve each equation for x. So I have x equals negative 3, or x equals 5. Now when I substitute it back in, no danger of division by 0. So both of these are my answers. Negative 3 and 5. Well, looks like they're getting a little bit more difficult as we go. That's to be expected though. Let's look at x minus 8 over x plus 2 equals x plus 9 over x plus 1. Now if you want to learn one way that always works, you multiply by the LCD. However, if you look at this, you can always crisscross multiply. By all means, do that if you want to. Highly recommend it. But I'm going to stay consistent and do the same process over and over again. Let's find the LCD. Most of each. This has, the first fraction has an x plus 2, second has an x plus 1. I need one of each. So it's going to be x plus 2 times x plus 1. Now what I'm going to do is, I'm going to write down each fraction and multiply each fraction by the LCD, which is going to be x plus 2 times x plus 1. Yep, could be quite a bit of writing here, but that's okay. You do what you gotta do. Now let's see what happens. Over here, these x plus 2's cancel, and it leaves x plus 1 times x minus 8. On the second fraction, the x plus 1's cancel, and it leaves x plus 9 times x plus 2. Looks like a mess, but it's really not. What we're going to do, we're going to full everything out on both sides. So this full x plus 1 times x minus 8, and we'll get x squared minus 8x plus 1x minus 8. Just stay on the left side. You get x squared minus 7x minus 8. Now let's pull the right side. You get x squared plus 2x plus 9x plus 18. Combine like terms, we get x squared plus 11x plus 18. And now let's solve for x. But notice we have x squares. We need the x squares on the same side. So subtract those off. And you'll notice x squared minus x squared is 0, which means they're gone, which is always good. So now we have negative 7x minus 8 equals 11x plus 18. The reason why it's good is we now have a linear equation to solve and not a quadratic, which would require factoring. This one doesn't. So let's solve these like I normally do, or like you normally do. I always start with the x terms, and I always start the smaller one, which in this case is a negative 7x. I'm going to add 7x to both sides. And then I'm going to subtract the 18 to isolate the x term. And then I'm going to divide both sides by 18 to isolate x. And I'm going to reduce negative 26 over 18. 2 goes in both of those. It goes negative 13 over 9. 2 goes into 26 13 times. 2 goes to 18 9 times. There's no danger at all of division by 0. So that's my answer. That was a fun one, wasn't it? Let's do a couple that are slightly more difficult. Now when you look at question E, you'll notice that one of these denominators factors. The x squared minus 16 does. And you'll notice we also have x minus 4 and x plus 4 in the other denominators. Can you guess how x squared minus 16 is going to factor? So let's go ahead and factor it. Let's go through the process. No GCF, no 4 terms. Does have an x squared term, no number in front, draw 2 parentheses, y times what is x squared, x times x, y times what is 16, 4 and 4, y times what's a negative, negative and positive. And something else that's special about how it factors. Guess what the LCD is going to be? Now we're going to have an x minus 4 and an x plus 4. There's only one in either fraction. Only one x minus 4 in either fraction, only one x plus 4 in either fraction. So therefore, our LCD is x minus 4 times x plus 4. So what that means is we're going to multiply each of those fractions by the LCD. And we're going to watch things cancel out. I may run out of paper, so I may have to extend it a little bit. Yep, these can get quite long when you write them all out. I may even run out the screen a little bit. I could sing to you while I'm writing these out, but I'm not going to. So here we go. Now I'm going to start canceling the denominators. X minus 4's cancel. Both of these cancel. X minus 4, x plus 4 cancel. And over here, the x plus 4's cancel. So now what that means is, I don't have any fractions, but it's got a lot of work to do still. So I'm going to go ahead and write down everything that's left over. So from the first fraction, I have 2x times x plus 4. From the second fraction, I have just the 10 minus 5x. And from the third fraction, I have x times x minus 4. See, everything else I canceled out. Now let's clean this up. I don't need those equals there. I already have the equals that I need. So let's distribute and see what happens. 2x times x plus 4 is 2x squared plus 8x. Nothing to distribute in the middle. X times x minus 4 is x squared minus 4x. Okay. Let's combine like terms where we can. You have 2x squared, and then 8x minus 5x is a positive 3x. Write down everything else. Now I have x squared terms. So I'm going to get those on the same side, so I'm going to subtract the smaller. We end up with x squared plus 3x plus 10 equals negative 4x. And you can combine steps. I'm just doing everything step by step. Now, since we do have x squared, that tells me that we're probably going to have to factor to solve it. In order to factor, we have to have every term on one side, and the other side has to be 0. So that tells me I got to add 4x to both sides to make the right side 0. And then I'll combine like terms on the left side, and I get x squared plus 7x plus 10. And then I have to factor. Anytime I have x squared, I'm solving, I gotta see if it factors. Now I don't have a GCF, don't have 4 terms. I do have an x squared with no 1, or with just a 1 in front. So I'm going to draw 2 sets of parentheses then, do the full method backwards. What times what is x squared? What times what is 10 that gives us a 7? How about a positive 2 and a positive 5? And I'm going to take each one of these and set them both equal to 0. X plus 2 equal to 0, or x plus 5 equal to 0. I'm going to solve by subtracting 2, so I get x equals -2. And for this other equation, I'm going to subtract x, or subtract 5 to get the x by itself, and I get x equals -5. Now, I do have answers of -2 and -5. I'm going to come back up here to the original problem and just check to make sure that both these are fine. If I throw in a -2, I don't get division by 0 anywhere. If I throw in a -5, I'm just looking at the denominators. If I throw in -5, I don't get division by 0 either. So both of those are the solutions. Phew, that was a long one, wasn't it? Yep, you got another long one, looks like. Now let's do this one. This is going to be a fun one. First off, factor the denominators that may need to. 3x squared plus 7x minus 6. You know, it would be really neat, or to your advantage if you can do this. If you can't do this, that's fine. Do the AC method. I don't see a GCF, don't see 4 terms, I do see squares, I do see number in front. You can do the AC method, but I'm going to show you there may be an easier way. I see squares, so I'm going to draw 2 sets of parentheses. So I'm thinking what times what is 3x squared? I only have one possibility, 3x and x. What times what is a 6? 1 and 6, 3 and 2. It's usually the first thing you think of, so let's try 3 and 2. If I put the 3 there and the 2 there, and I check it, the outers, that gives me 9x, inners give me 2x. 9x and 2x gives me a 7x. To have a positive 7x, then you make that 3 a positive and 2 a negative. Now if you don't like that, do the AC method, grouping method, but I'm trying to save some a little bit of time, so that's why I did that. Minus 1 over x, because nothing factored there, equals 4 over, when I look at this, I see a GCF. GCF is x. So when I take out the x, when I divide by the x, I get 3x minus 2 left over. Now I'm ready to find the LCD. So, start over here. You gotta have a 3x minus 2 in it. So I'm gonna write that down. Gotta have the x plus 3, so I'm gonna write that down. Have to have the x, so I'm gonna write that down. The x that stands alone, not an x that's connected to something else, but an x that stands alone. Come back over here, I have the x that stands alone, and I also have a 3x minus 2 already accounted for. So this is my LCD. So now what I'm going to do, first I'm going to zoom this a little bit, make sure the lighting is proper so it doesn't blind you. Now what I'm going to do is I'm going to take each one of these fractions and multiply by the LCD. I'm going to write kind of small so I can get it all on one page. So 3x over 3x minus 2 times x plus 3 times that by the LCD, which is x, 3x minus 2, x plus 3, minus 1 over x times x, 3x minus 2, x plus 3, equals 4 over x times 3x minus 2, multiply that by the LCD, which is x times 3x minus 2 times x plus 3. Like I said, I'm just trying to get it all on one page. Come back to the first fraction, the 3x minus 2's cancel, the x plus 3's cancel, and it leaves 3x times x. For the second fraction, the x's cancel, and it leaves minus 1, which I'm not worried about 1 since it's been multiplied by the 3x minus 2 times x plus 3. And then to the last fraction, x's cancel, 3x minus 2's cancel, and it leaves 4 times x plus 3. Now I'm going to clean this up. 3x times x is 3x squared. Going to distribute or foil the 3x minus 2 times x plus 3. We're going to get I'm going to do some little shortcuts here. I'm going to combine a couple steps, and I get 3x squared plus 9x minus 6. Now, since it's subtracting all of that, and by the way, that's not 9x, it should be 7x when you finally work it all out. I'm going to put that in parentheses because I want to make sure the minus sign is in front of the whole thing. Equals 4x plus 12 is what I get when I distribute. Let's continue on with the distributing. So I want to distribute the minus sign. So I distribute the minus sign throughout the parentheses. I get minus 3x squared minus 7x plus 6 equals 4x plus 12. Notice these 3x squared are the same. Anything subtracted from itself is 0, so they're gone. And it leaves negative 7x plus 6 equals 4x plus 12. I'm going to solve the linear equation by starting with the smallest x term. So I'm going to add 7x to both sides. And I'm going to get 6 equals 11x plus 12. I'm going to isolate the x term by subtracting 12 from both sides. And we get negative 6 equals 11x. Going to divide both sides by 11. We get our final answer of x equals negative 6 over 11. Now, since we have negative 6 over 11, is there any possibility that we substitute in will we get a negative number, or a 0, I mean, do we get a 0 in the denominator? No, because I can look in the factored form and see that I can't get a denominator of 0. So that's our final answer, negative 6 over 11. Now, let's do one more. An easy one, just so you can see what I'm talking about when I say division by 0, when you want to check your answers. It's from the LCD. They happen to be the same thing, so it's x plus 2. So I'm going to multiply both fractions by x plus 2. This should be a fairly quick one. Now these x plus 2's cancel, and it leaves x plus 1. These x plus 2's cancel, and it leaves the negative 1. I want to solve for x, so I'm going to subtract the 1 from both sides, and I get x equals negative 1 minus 1 is negative 2. But watch this. So when I substitute the negative 2 into the denominator up here, we get negative 2 plus 2, which is 0. We can't have division by 0. What that means is negative 2 is not the solution. Nothing else can we try, so there is no solution. So one way to write that is empty set, no solution. So be aware, that's why we're always checking our answer for division by 0. Always do that.